Find the derivative of y equals a polynomial divided by a polynomial. Well, if you have a polynomial divided by a polynomial, the best thing to do is use good old quotient rule. What's quotient rule? Well, you label the numerator u, you label the denominator v, and do u prime v minus v prime u over v squared. So we know what u is. We know what v is. We are going to find u prime and v squared. So u prime is going to be the derivative of this numerator. So the derivative of 4x to the third, power rule, multiply 3 times 4 is 12, subtract 1 from the exponent, x squared, minus multiply 2 to 3, which is 6. Turn that 2 into a 1 after you subtract 1, and that's u prime. V prime is going to be the derivative of the denominator. 4 times 5 is 20, so we got 20, subtract 1 from 5, that gives you 4. Minus 4's derivative becomes nothing, so that's nice. I also have to find v squared. Now, v squared is going to take this entire denominator and square it, which means it's not going to be this times this minus that times that. If you square it, you have to do perfect square trinomials. So that actually simplifies out to 4x to the 5th times itself, so 16x to the 10th. Multiply these two together and multiply it by 2. So 4x to the 5th times negative 4 is negative 16x to the 5th times 2 is negative 32x to the 5th. And then square that and you get 16. So let's find the derivative. Let's put it all together. Y prime. Y prime is going to equal u prime, which I said was 12x squared minus 6x times v, which is green, 4x to the 5th minus 4 minus v prime, which I made purple, so 20x to the 4th times u, which is red, so many colors, 4x cubed minus 3x squared, that's that. It's all going to be over 16x to the 10th minus 32x to the 5th plus 16. So let me FOIL this out and then distribute that and see if any magic happens, see if anything disappears. It's possible. I don't know. Maybe I could do some factoring. Maybe, maybe not. We'll see. 12x squared times 4x to the 5th is going to be 48x to the 7th. 12x squared times negative 4 is negative 48x squared. Negative 6x times positive 4x to the 5th is negative 32x to the 6th. Negative times a negative is a positive 24x. This distributes, so negative 20x to the 4th is going to give you negative 80x to the 7th when you multiply it by 4x cubed. And negative 20x to the 4th times negative 3x squared is going to be positive 60x to the 6th. All of that, all of it, still over 16x to the 10th minus 32x to the 5th plus 16. All right, so let's see if we can do some combining, and I'll bring it over here just in case there's more factoring going on. I'm not sure what my answer is going to be. I'll go standard form, biggest degree first. 48x to the 7th minus 80. X to the 7th is going to be negative 32. X to the 7th. Let's get a different color out here. Negative 32x to the 6th plus 60x to the sixth is 28x to the sixth. I had to think about that for a second there. That's supposed to be x to the sixth. What else? Nothing else combines. So negative 48x squared plus 24x. All right. I think I'm good. 16x to the 10th. Oh my gosh. 16x to the 10th minus 32x to the 5th plus 16. The only thing that I can do, and I'm running out of space here, so I'm going to do this all in my head. I can factor out a 4 up top. I can factor out an x up top. But if I factor out an x up top, that does mean nothing for the bottom. But if I factor a 4 out on top and factor a 4 out on the bottom, all the 4s disappear. So what I'm going to do is I'm going to literally divide each and every one of these guys by 4. That'll get me my final answer. So negative 8. 7x to the 7th plus 7x to the ugly looking 6 that was minus 12x squared plus 6x all over 4x to the 10th minus 8x to the 5th plus 4. Never said it would be pretty. I just said it would be fun. And that's quotient rule for you.